I agree with you that GitHub Copilot is probably the first example of an AI assistant increasing people's productivity. In fact, based on some of the studies that is done at Microsoft Research where I work, GitHub Copilot can double up the productivity of a software developer. And there are different reasons why software engineering or development is such an useful and appropriate domain for AI assistants to come in. First of all, the nature of the work is all language, coding, and natural language. And second, the information for completing many programming tasks are actually embedded in the project and does not require much external um, context to be able to accomplish. And for those reasons, of course, even we are seeing that even code completion, a very simple form of code completion, can be extremely productive for developers because it helps the developer to stay in context in the task without having many interruptions of going to different search engines and finding the information. The information is at their fingertips. So those are the reasons why we are really seeing an significant productivity jump from tools like GitHub Copilot or Cursor. Coming to your question about what other domains are useful for this, we are seeing that any kind of writing domains, creative writing, or just writing for official documents, are again carrying out many of those examples of work being done in language and LLMs being super powerful. But at the same time, there's so many different efforts for making this assistant technology expanded with memory, with actions, with adaptation to different domains that I'm pretty certain that we are going to be seeing a similar productivity gain for other domains, for office workers, for education settings, for healthcare settings as well. It's just going to take a little bit more of expanding the infrastructure of these systems to get there. The uncertain nature of LLM execution is definitely a challenge that we need to overcome as we are building reliable systems. Traditional software systems are built with the assumption that there is a deterministic logic that oversees the work that is getting done, and LLMs do not work that way. There is an holistically stochastic process that's happening in LLMs. At the same time, we are seeing a system level work and an interaction level work that is happening to overcome some of the limitations of LLMs in terms of their stochastic nature. There is definitely work happening in terms of improving the models themselves to have a notion of uncertainty and using that in the way that tasks are being done, but also bringing external verification and validation steps on top of LLMs to be able to check for information correctness. And that seems to be another useful approach for reducing the hallucinations that happen in the system. And finally, there are interventions that can be done at the interaction layer itself, where humans can be made aware of different weaknesses that these systems have so that they can be informed about such limitations and actually override or overcome them as they do the work. So yes, LLMs have limitations, but as the new computing stack is emerging, we are seeing interventions and improvements that can be done across the stack to make those problems much less obvious. There are a number of interesting questions that are coming up to make sure that human AI collaboration is going to be working in the right way. First of all, there is an issue that AI systems can be overly confident and may not have a good idea of what they don't know. And that kind of confidence may convey a uncalibrated belief to a person so that the person may not even check what the AI system is doing. And as we discussed, like methods to be able to calibrate AI systems better or express uncertainty can be very effective for the human to understand when they need to complement what the machine is doing. Second, it is really about the awareness and the education of the people interacting with these systems as well. Overcoming the hype, making sure that every user of these AI systems understand that these systems have limitations and the human oversight over the execution of these systems is important, are major educational and awareness challenges that we need to overcome it. And then the other part, which is a longer term challenge, is that people using such AI systems and assistants, their behaviors and knowledge are going to be changing in time as well. Um, Not doing some task over a long period of time or getting too used to using an assistant may start changing the human behaviors too. So we are probably going to be seeing a future where AI systems and people are going to be evolving together. And we have to watch both how the human autonomy, accountability, and the skills are staying intact as that evolution happens. Everybody is asking this question about scaling laws and how are we running to an end of a scaling law with respect to training models. First thing is, for frontier models, it is indeed the case that more data and scale brings more capabilities. But soon after a frontier model gets to that level of capability, we are seeing that the community is finding really creative and innovative ways of getting to that level of capability with less compute and less cost. For example, for my lab inside Microsoft Research, we have been developing 5 model series, which are small language models, but with careful data creation, they can be as effective as models that are much larger in size. And I believe this trend of, yes, we are going to have frontier models and they will need to scale further, but there are going to be models medium size or small size, and they can be orchestrated together to carry out different activities. It's going to be very important to get to capable systems, but they are also efficient and scalable and environmentally friendly. But getting to your question about data, we are also seeing some advances in terms of synthetic data generation that can be coupled with real data to expand the data that these systems can learn from. And of course, with now advances happening in RL training and inference time compute, I think we are going to be getting to a completely new phase of training of these models that are not only dependent on static data, but it also depends on experiences that these systems can get from the real world. The upper bound for me for these approaches is not so much the artificial general intelligence or getting to generalizability, but it is really for these systems to reach a level of usefulness, reliability, and safety, whereas people, we can be confident about the value we are getting from these systems, and we can have guarantees about their safety and their the way they behave in the world. In fact, for many of the applications I really care about, I don't think having general AI systems is really a necessity. It's a useful ingredient if we can get them. But even with the current models, with good engineering, we can really develop useful systems, and I think that's really a great progress to see for our field.